Hello students, today we solve one board question. The question is an electric field E vector equal to 10x plus 5 I cap Newton per coulomb exists in a region in which a cube of side L is kept as shown in figure. That is, there is an electric field in a region and we placed a cube, that is closed surface, which is having side L in that region. Here x and L are in meters. Calculate the net flux through the cube. We know when we place the surface in a region of electric field, the electric field lines are passing through the surface and the number of field lines passing through the surface is known as the electric flux. Here we placed the cube in the region of electric field, so the electric field lines are passing through the cube. We need to find the total number of field lines, that is net flux through the cube. We know flux is the dot product of electric field and the area vector. So we must know the electric field and area of each surface of the cube to find the net flux through the cube. The given electric field is 10x plus 5 I cap. That is, the electric field is along the positive x direction and it is the function of x. We know there are 6 surfaces in a cube. We label the 6 surfaces and electric field is passing through the surface 1 and 2. Because these two surfaces are perpendicular to the field lines, so the electric field lines are passing through the surface 1 and 2. Now what is the electric field at the surface 1? The electric field at the surface 1 is 5 Newton per coulomb because the surface 1 is placed at the origin of the x-axis. So if we substitute x equal to 0, the electric field at the surface 1 is 5 Newton per coulomb. What is the electric field at the surface 2? The surface 2 is placed at L meter from the origin of x-axis. So if we substitute x equal to L meter, it becomes 10L plus 5 Newton per coulomb. So the field lines are passing through the surface 1 and 2. So what is the flux at the surface 1 and 2? Flux is the dot product of electric field and the area vector. Here the angle between the electric field and area vector is 180 degree because they are anti-parallel. Here the field line is entering and area vector of the surface is towards the left side. So the angle between the electric field and the area vector at surface 1 is 180 degree. We know cos 180 degree is minus 1. So flux at the surface 1 is minus E1 S1 and area of the surface is L square. If we substitute, we get minus 5 L square. So this is the flux at the first surface. And what is the flux at the surface 2? At the surface 2, the angle between the electric field and area vector is 0 degree. That is, the electric field and area vector are parallel and we know the electric field at the surface 2 is 10L plus 5 and area is L square. So if we substitute, the flux at the surface 2 is 10L cube plus 5L square. So the field lines are passing through the surface 1 and 2 and no field lines are passing through the remaining surfaces because in the remaining surfaces, the angle between the area vector and the electric field is 90 degree. Cos 90 degree equal to 0. So no flux through the remaining surfaces. Flux is through only surface 1 and 2. So the net flux is the sum of the flux through surface 1 and surface 2. We know what is the flux through surface 1 and surface 2. If we substitute, we get net flux through the cube is 10L cube voltmeter. So the net flux through the cube is 10L cube voltmeter.